Here we are in section 2.3 with exercises 13 through 24. We're doing absolute value inequalities. We've got to solve them, graph the solution, and then have the answer in both set and interval notation. Now notice here, absolute values, when we deal with them with equations, we split them into a plus and a minus. When we have inequalities, remember we split them into the positive one, that's great, and it looks just normal, and the negative one flips the sign. Here's a reminder that if it is the absolute value is less than something, that means the distance of whatever numbers we're talking about are contained within a certain radius, so it will always be an and statement. And if it's greater than or equal to, then it's an or statement, so it's going to flip out towards infinity in either direction. So that'll help us do these. All right, number 13. Here we have the absolute value of x is bigger than 3. So when it splits into two things, let's do it down here. We have the absolute value of x is bigger than 3 splits into x greater than 3, just like normal. And then it splits into x is less than negative 3. All right, okay, and this is a greater than. The absolute value is greater than something, so this is an or statement, and that is our solution. I guess we could put it in official set notation so it looks pretty. There we go. On the graph, it looks like this. Here's 3, and here's negative 3, and it's bigger than 3 or less than negative 3. And the interval notation looks like this: negative infinity up to negative 3, not including negative 3, union, or 3 to infinity. Excellent. Number 14. X minus 3 is greater than or equal to 17. So this is going to split into what looks normal, x minus 3 greater than or equal to 17, or x minus 3 is less than or equal to negative 17. Remember, when we split the negative one, we flip the sign, so it's less than or equal to. So we get x is less than or equal to, add 3 over here, and it's negative 14. Or we get add 3, and x is greater than or equal to 20. And there we have our set version of the solution. So if here is 20, and here is negative 14, this is a solid bracket because we're including the number 20 before we shoot off to infinity there and down that way. So the interval notation is negative infinity to negative 14, including negative 14, not infinity, union 20 to infinity. Great. Number 15. This is a less than, so this is going to be 5x plus 1 less than or equal to 3 and greater than or equal to. Notice we just flipped the sign around. Even though it looks like it's the same direction, 5x plus 1 is now on the other side of it to get the negative 3, and it is less than, so this is an and statement. Notice that this 5x plus 1 has to be trapped in between 3 and negative 3 in order for this to work. So we subtract 1 from all three sides, and we get negative 4 less than or equal to 5x less than or equal to 2. And then divide by 5, and we get negative 4/5 less than or equal to x less than or equal to 2/5. This is the set notation of our solution right here. We have 2/5 right here and negative 4/5 right here, and we are trapped in between them, and we are equal to them like this. So the interval notation is negative 4/5 to 2/5, including both endpoints. Great. Let's clear this off and look at the next three. Number 16. Here we have these 3x minus 3 is less than or equal to negative 5. Now you might want to notice something weird is going on here. This is a negative number, but watch what happens when we try to do it right. 3x plus 3, it's less than, so it's an and, less than or equal to negative 5, greater than or equal to the opposite, which would be a 5. Notice what we just wrote. Getting rid of this middle part right here, we just wrote that negative 5 is bigger than 5. That is not possible. There is no solution. You could see that without doing anything. This over here is positive. Is positive ever smaller than or equal to a negative 5? No. So no solution. No graph, no interval notation. All right, number 17. So here we have negative 2x plus 6 less than 18 and bigger than negative 18 at the same time. And again, this is negative 2x plus 6 greater than, notice the sign is switched, negative 18, but we turned it this way to write it as an AND statement. So this guy has to be trapped between 18 and negative 18 to make it work. So subtract 6 from all three sides, and we get negative 24 less than negative 2x less than 12. Now we divide by a negative 2. Now notice as we're dividing by this number, it is a negative number, so this becomes 12 is bigger than x is bigger than negative 6. And notice this makes sense. If we didn't switch it, that would not make sense to have negative 6 bigger than 12. So there's a 12 here, and there's a negative 6 here, and x is in between these two. And do we include the endpoints? No. So it is a parentheses, much like an open circle. So we have negative 6 to 12, like that. And let's write the set notation, interval, and graph. All right, number 18, 3x minus 5 greater than or equal to 14 in absolute value. So this splits into 3x minus 5 greater than or equal to 14, or remember, this is an OR statement. If the absolute value is greater than something, 3x minus 5 less than or equal to negative 14. All right, let's solve these guys. Add 5. 3x is less than or equal to negative 9. X is less than or equal to negative 3. Or add 5, and we get 3x is greater than or equal to 19. And divide by 3, x is greater than or equal to 19 thirds. All right, there is our set notation. Let's do the graph. Here we have negative 3, and it's equal to and less than. And here we have 19 thirds, just over 6, and it's greater than or equal to that. Good. Okay, and notice what's happening is this distance is greater than 14, this absolute value. So that means, yeah, we're going to shoot off to positive and negative infinity, because we have to be outside of whatever criteria or fence exists there. So interval notation is from negative infinity to negative 3, including negative 3, union, meaning or, 19 thirds to infinity. There we go. Set, interval, and graph. Number 19. 6y plus 1 greater than 3. So this is 6y plus 1 greater than 3. Split it the other way. It's greater than, so this is an OR statement. 6y plus 1 is less than negative 3. So yeah, we're shooting off to infinity. We either have to be bigger than 3 or less than negative 3. And solve each of these. 6y subtract 1 is less than negative 4. And we get y is less than negative 4/6. If we divide that off, that's a negative 2 thirds. Or subtract 1, we get 6y is greater than 2. Divide by 6, and y is greater than 1/3. So we write that with the pretty braces, and we now have set notation. There's our solution. Graph it. Here's 1/3, and here's negative 2 thirds. So 1/3, we're going to be greater than that, not including the number, and less than negative 2 thirds, again, not including negative 2 thirds. So the interval notation will look like negative infinity up to negative 2 thirds, and union 1/3 to infinity. Excellent. Next one. Number 20. Something shady is going on here. We could just look at this from the beginning and say, hey, this is a positive number bigger than negative 4 will always work. But let's do it slowly and by hand, and we'll see what happens. This is negative 2x plus 3 is greater than negative 4, or negative 2x plus 3 is less than the opposite of this, which is a 4. And we get, subtract 3, we get negative 2x less than 1. X, divide by a negative 2, remember, switch the sign, x is greater than negative 1/2. When you divide by a negative number, you switch the sign. Or subtract 3 and we get negative 2x greater than negative 7. Divide by negative 2 and we get, switch the sign, x less than 7 halves. Notice this right here. If we were to graph this, here's negative 1/2, and we're greater than or equal to, no, just greater than, sorry, that's a curved parentheses there, or x is less than 7 halves. Now, this is an or statement, and that's why this is so crucial, that it's always an or statement going that way. Oh, yeah, look at that guy. The or statement, that is all real numbers. So it's negative infinity to infinity. And it's just, you don't even need to see those braces. It's just the whole number line. Good deal. On a set notation, I guess you just write all real numbers. So yeah, we could have looked back at this one and said, hey, this is always positive. Positive is always bigger than a negative 4. So all real numbers are going to work. Doesn't matter what you stick in there. When you take the absolute value, you get a positive number. It's bigger than negative 4. So number 21. Let's do that one. We have 6m minus 5 is less than 3 and bigger than negative 3 at the same time. So we get to write it as a compound inequality. Add 5 to all three sides and we get 2 is less than 6m is less than 8. Divide by 6, divide by 6, divide by 6, and we get m is less than 4/3 greater than 1/3. And there is our set notation. So here's 1/3 here and 4/3 there, and we are in between those two. And we do not include because we're not equal to, so it will be an open parentheses, and it's 1/3 to 4/3 parentheses. Excellent. Number 22. All right, we see a strange thing happening over here. Negative. Let's not go through the whole kit and caboodle. This is a positive. How often is a positive number bigger than or equal to negative 3? And it is always. I'm going to write that down. That means we get all real numbers for x. X equals all real numbers. That is the set of solutions. Interval notation would be from negative infinity to infinity. That's everything. And the graph looks like this, going in both directions. Number 23. 3 minus 3r greater than 10. Absolute value of that greater than 10. This is an or statement because we got to be bigger than 10 or less than negative 10. 3 minus 3r is bigger than 10 or 3 minus 3r is less than negative 10. And subtract 3 from both sides. Negative 3r is less than negative 13. Divide by a negative 3, divide by a negative 3, and we get r is greater than 13/3. Or finish the other one, subtract 3, and we get negative 3r is greater than 7. Divide by a negative 3, divide by a negative 3, and we get r is less than negative 7/3. Remember, when we divide by a negative, we switch the direction. So, set of all r such that that takes place. That's our set notation. Let's graph it down here. Here we have 13/3, and here we have a negative 7/3. We are less than negative 7/3 going down that way with parentheses because we are not equal to those endpoints, and up that way. So the interval notation will look like this: negative infinity up to negative 7/3, union 13/3 up to infinity. Excellent. And number 24. We have 12m minus 9 is less than negative 6. Oh, look at that. We have a negative number. Let's not go through the whole rigmarole. This is always a positive number. We know that it's always a positive number. Can it ever be less than negative 6? No, it cannot. No solution. So this is, there is no graph. Yeah, or that's what the graph looks like. Not really a set way of writing that. Great.